So I've already made a video on concatenations. This is a sort of sequel. I'm asking the question, what if there are more than two inputs? So I've already made a video on concatenation where we take two inputs, such as, 17 and 390, and we kind of mash them together to form a new number, 17,390. And that's essentially what this formula tells us, that when you take two numbers, you kind of can mash them together using that formula. But what if there are more than two inputs? So that's what we're going to be investigating in today's video. So hopefully you enjoy. So essentially, we should start by just observing, looking at how things work. So let's take two numbers, let's say, or three numbers actually. So let's take 17, 390, and 6. Okay, so we have these three numbers, and we're going to concatenate all of them using this notation. If you are unfamiliar with this, I'll leave a link in the description to my first video on concatenation. And yeah, so we're going to take this, and we obviously know by just looking at this that this will be 173,906. So that's going to be our final result. So how do we get that? Well, let's break this number down. So using what we saw in the last video, we can kind of see that this is going to be 170,000 plus 300 plus 3,900 plus 6. Alright, so this, I'm going to underline it in blue. So the 17 is our number. Let's underline it more. This 390 is our second number. Notice how I include the 0 because that's part of our number. And then we have the 6 there. Alright, so these are our digits, and they all combine to form this number. What's significant about this is that we have 4 trailing zeros. So let me say 4. Let me just do 4. Alright, and here we have 1 trailing 0. And then, of course, in the second part, or in the third number, we don't have any trailing zeros. So, well, why? Why do we have these specific numbers of trailing zeros? And that's because that's the number of digits that follow. So the number of zeros in this first number is dependent on the number of digits of the second two numbers. That's where that log of the ceiling of log, that 10 to the ceiling of log b comes in. That tells us how many digits are in a number. So 10 to the ceiling of log of 17 is going to give us 2, because it has 2 digits. So I'll just put d here. So we have 2, 3, and 1. And you can test that out for yourself, and you'll see that basically that works. So yeah, basically we're going to use that to help us out. So 4, it comes from these two numbers, which is 4 digits. So let's just kind of use that. So we take the 17, which is our initial number. Let me do that. Let me do this in red here. So 17 is our initial number, but then we multiply by our 10 to the log of 390. So 10, let me just do 10 to the ceiling of log 390. But that's only going to give us 3, because this is a 3-digit number, so putting it into that is going to give us 3. We need 4. Well, that comes in from the 6 at the end. So we're going to multiply by 10 to the log of 6, the ceiling of log 6. Okay, but then what we do is we take the 390, so I'm going to add 390, and then we're going to multiply by 10 to the, well, we have 1 digit trailing, so it's going to be that 10 to the ceiling of log 6. And then we just add our 6. So that's just plus 6. And we don't multiply by anything. I mean, we really just multiply by 1, so I'm just going to write that out because that'll be significant later. And so this is our process here. We're taking these 3 numbers, and this gives us our number. So what we notice is that if we did, so we can notice a pattern, because whenever we have two inputs, we have this pattern. Whenever we have 3 inputs, we have this sort of pattern. So you can guess that whenever we have 4 inputs, we're going to have 10 to the log of the second times the third times the fourth numbers, and then the second, and then third times the fourth, and it's going to keep going. So we can write this in terms of a sum and a product. So we're going to start with the sum part, because obviously the outside portion is a sum. We're adding all these together. So we're going to start with n equals 1, and we're going to go to k. But this doesn't really tell us much because we don't really know what k is. So first we have to define this. So this is the concatenation from a sub 1 all the way to a sub k. Alright, so we start with a sub 1, and we're going to concatenate like repeated terms, that's what the dot 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 means, all the way to a sub k, where k is our last term. So we're going from n equals 1 to k, and so we start with that term. So I'm going to say a sub n, actually this is, I'm going to write m here. So a sub m, and I'm going to put this in parentheses, and then we're going to multiply by, well, what? Well, we're going to multiply by the product of everything that follows. Everything that follows, starting at the second term, because this is our second term, all the way to the last term. So a sub m times the pi, the big pi, from, now I'm going to use n, equals m plus 1, because we're starting at the next term after that, all the way to k again. And we're going to just put in our 10 to the ceiling of log of n, expression here. Just log of n. Let me close the parentheses. And that is our entire function. This is the concatenation of k terms. So concatenation of k terms. And that's a crazy formula. So we have a sum and a product, and we're taking all of these things together. But you can see that it'll work for this because we only have 2 terms, so we're going from 1 to 2 of, it's just a very basic, 1 to 2 again. Actually, this is 2 to 2, so it's a really basic thing. So let's actually prove that this works by using another example. Because we can't just prove it with one example. We're going to use 4 terms here. Actually, let's use 5 terms, just to make it a little more, like, proofy. So, let's say we have 160, 16, actually, no, I don't want to use 16, 18, 10,000, 056. It really doesn't matter what we use. I'll put a 1-digit number in there, and then I'll put like 4 digits, so 146. Yeah, that's our number. All right, those are our 5 numbers, and we're going to concatenate all of these together. All right, and so we should end up with 160181005671462. And I'm not going to bother with the commas there because it's not going to matter later, because we're going to end up with a long string of numbers anyway. So, essentially, we're going to start. So we're going to take the sum from 1 to 5. So let's start. We're going to always start with our first term. So I'm just going to write each of our first terms down. So we have 160. Then we have 18. We have 10,056, 7, and 1462. Alright. So I'm just going to add all of these together. Okay. And so then we're going to take we're going to take the product side, so I'll just keep it in black. So then we start at, and you can actually condense it to be, since you're adding a bunch of these, you're multiplying a bunch of them, you can add the exponents together because it's the same base, so that's what I'm just going to do just for simplification. So 10 to the log, ceiling of log of 18, plus ceiling of log of 10,056, plus ceiling of log 7, plus ceiling of log 1462. Alright, and then you can repeat the process all the way down. So I'm just going to skip to that. Alright, so at the end, you don't have anything to multiply, so it's 0, and 10 to the 0 is just going to be 1. So you can kind of just erase this last term, and that's why you add the last term at the end. And so once you sum all this up, basically you just add up all these digits. So we have, I'll just write it in blue at the end here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 digits, so it's going to be 10, oops, that's going to be 10 to the 12. 10 to the, I'm sorry, I'm going to do it this way then. So it's going to be 10 to the 12, right? Then we have, okay, minus those, so that's going to be 10 to the 10. Then we have minus those 5, so that's going to be 10 to the 5th. Then that's just going to be 10 to the 4th. And then at the end, it's going to be obviously 1. So I'm not even going to put it. So essentially, we have 160 times 10 to the 12 plus 18 times 10 to the 10th times 10,056 times 10 to the 5th, or yeah, and then plus 7 times 10 to the 4th, and then plus 1462. And that, if you compute it, it's going to add up to this crazy number. And so that's basically all it is. And it's a simple process. You start with the first number and you multiply by all the other numbers in this little formula here. And it's just the notation's a little scary, but other than that, it's a really simple process. And that's concatenation. It's a very natural, flowing thing. You just take two numbers, put them together, but it has a really interesting formula, and that's what is very interesting to me. So, thank you all for watching, and I will see you in the next episode. Bye.